Good morning, students. Welcome to our online video class of chemistry. In this video, we will discuss about what is complex reaction and difference between order and molecularity and integrated equation for first order reaction.
Complex reaction. What is a complex reaction? A chemical reaction may not always take place in a single step, and a chemical reaction which takes place through a sequence of two or more steps are called complex reaction. And each individual step of complex reaction which contribute to the overall reaction is called elementary process or elementary reaction. And the net reaction is a combination of these elementary reaction. For example, NO2 plus CO gives NO plus CO2. This reaction which takes place in two steps. In the case of multi-steps reaction, the different elementary reaction which usually have different rates. Some of the steps will be fast while others will be slow. And the rate of overall reaction is determined by rate of slowest step. Slowest step of a complex reaction is called rate determining step. In this example, NO2 plus NO2 gives NO plus NO3. This step is slow step. And next step is NO3 plus CO gives NO2 plus CO2. This is fast step. And overall reaction is NO2 plus CO gives NO plus CO2. In this reaction, the rate determining step is this step, the slow step. Then rate equals NO2 square. This is the rate determining step.
In the case of complex reaction, molecularity is assigned to each elementary reaction. Therefore, molecularity has no significance in complex reactions. We have learned about what is order and molecularity and what is the difference between them. Molecularity and order. Order is the sum of the power of concentration term in rate law. And molecularity, it is the number of reacting molecules, atoms or ions which collide simultaneously to bring about the reaction. Then order is experimental quantity and molecularity is theoretical concept. Order can be zero and even a fraction. Molecularity be zero or non-integers. An order is applicable to elementary as well as complex reactions. And molecularity is applicable only for elementary reactions. For complex reaction, order is given by the slowest step. Individual step has its own molecularity. Integrator rate equation. Now we are going to discuss about what is integrator rate equation. Equation obtained by integrating the differential rate equation to give a relationship between directly measured experimental data, that is concentration at different times, and rate constant is called integrator rate equation.
Integrated rate equation for first order reaction. In first order reaction, the rate of reaction is directly proportional to concentration of the reactant. Consider a general reaction for the first order reaction, that is A gives the product. Let A be the molar concentration of reactant A at any time t.
Then for first order reaction, instantaneous rate equals minus dA by dt. Minus d of molar concentration of A by dt equals K into molar concentration of A. Rewrite the equation, we get minus dA by A equals K dt. And integrate this equation on both sides. Minus dA by A, which is equal to log A. Log of molar concentration of A equals K integral dt. Integral of dt equals T. Then on integrating this equation, we get minus log A equals Kt plus I, where I is the constant of integration. Constant of integration. The value of I can be calculated from initial condition. Let A naught be the molar concentration of A at the beginning of the reaction. That is when time t equal to 0. Then substituting this condition in equation 1. This is equation 1. And on substituting the condition in equation 1, what is equation 1? Minus log A equals Kt plus C. This is the condition. Log A changes to A naught equal K into T. At this condition, T equals 0 plus C, not C, I. Then we get I equals minus log A naught. Minus log A naught equal I. And substitute the value of I in equation 1. We get minus log A equals Kt minus log A naught. Then log A naught minus log A equals Kt. Then log A naught by A, log A naught by A equals Kt. Because log A minus log B equals log A by B. Or we can write K equals 1 by T into log A naught by A. Converting to logarithm, we get K equal 2.303 by T log A naught by A. And this equation K equals 2.303 by T log A naught by A is the integrator rate equation for first order reaction. The first order reaction K equals 2.303 by T log A naught by A. And this equation can also be written as alternative form. As an alternative form. Let initial concentration of A be taken as small letter A moles per liter. Suppose in time t H small of A. Suppose in time t H smalls of A has changed to product. Then concentration of A at time t is A minus X. This is the concentration of A
at time t. Therefore, A naught equals A and A equals, molar concentration of A equals A minus X. Then substitute these values in this equation. We get K equals 2.303 by T log, what is A naught? Yes, A divided by A minus X.
A plot between log A versus T time gives a straight line. Is a straight line with a slope equal to minus K. A is the concentration of reactant after time t. The unit of rate constant is second inverse.